Who pays when 65 gigawatts of data centers come for one power grid? Texas just froze new approvals while it audits that entire queue, trying to make sure that the bill lands on the companies building them, not the people already connected to the grid. It is a major reversal from the state that has courted the data center boom more aggressively than almost anyone. Now here's the claim I'll stand behind. The AI build-out needs to move fast, but it cannot do so by hiding its costs or forcing the public to absorb them. If the AI companies want the grid, the AI companies should pay to build it. Come with me, let's get into it. On Monday, Texas ordered an audit of pending data center requests to connect to the ERCOT grid. It also paused new grid connection approvals until that audit is done. Texas has spent years courting one of the country's largest concentrations of AI compute, and now it's asking what each new project will take before it lets that project plug in. Operators have to report their water use, their tax breaks, their cooling systems, and their ownership. ERCOT, which runs the mostly isolated Texas grid, has also postponed its first capacity study for a queue estimated at 65 gigawatts. That's more electricity than the peak demand of entire countries. The immediate pressure for this came from a 15-hour state Senate hearing. More than 200 people spoke against a $33 billion transmission plan for the Permian Basin. Rural landowners packed the room. Even singer Tanya Tucker joined them. Days later, state leaders asked regulators to pause that transmission build. All right, so we need some proportion here because the data center debate often loses it. The viral line that one ChatGPT query drains a bottle of water actually collapses when you look at it closely. Across the whole country, data centers still use a pretty small share of water compared with agriculture and ordinary industry, even though it is true that their share of power demand is significant and growing. But the issue is that national totals looked at on the macro like that can actually hide a severe local micro burden. One campus can strain the wells in one dry country. One company can run unpermitted gas turbines beside a majority black neighborhood, as Saturday's edition documented with the example near Memphis. The people who end up bearing these costs often are those who have the least power to challenge them. And when an affluent community blocks a project outright because they have the money and the capability and the lawyers to do so, then the developer may simply move it somewhere with fewer lawyers and less political leverage. That's why a blanket ban solves the wrong problem. The transmission needs the infrastructure. That is a fact. The public also deserves a build-out that pays its own way and answers to the people living beside it. A federal bill introduced on Monday goes after the payment mechanism directly. It would make the largest data center operators cover their own interconnection costs. That means the new lines, the substations, and the grid upgrades needed to connect a huge electrical load. Utilities have often spread those costs across everyone else's monthly bill, even when one corporate project caused them. The bill's sponsor, Senator Martin Henrich, said that pledges are great, but show me the reality. And he also warned that a patchwork of local bans could trigger a race to the bottom, pushing construction toward whichever community has the least power to resist, as we just talked about. Texas's audit can supply the missing ledger. Regulators can't send a cost back to its source when the owner, the subsidy, water demand, and the cooling system remain hidden. Once those facts are on paper, a developer pays rule becomes much easier to enforce. Other states can copy the mechanism without inventing it from scratch. The build-out keeps moving. The subtle transfer of its costs onto households and vulnerable communities becomes much harder to preserve. All right, so the fight over who pays for physical infrastructure then leads to another question: who controls the intelligence running inside it? European companies are starting to answer that through their contracts. Mistral, the French AI lab, told Wired that its revenue has grown roughly 20-fold. European manufacturers, utilities, and banks are moving toward models that they can run on their own hardware. Those are open-weight models. Their learned parameters can then be downloaded, so a customer doesn't have to depend forever on a U.S. company's online service. That shift reportedly sped up after the U.S. export restrictions narrowed access to some of Anthropic's most capable systems. The recent agent escapes also unsettled security teams. For a bank or utility, running a model inside its own environment offers control over access, updates, and sensitive data. Now, Mistral has raised about $2 billion and is reportedly seeking a new round near a $23 billion valuation. Its business now leans into smaller models tuned for specific industrial jobs, supported by cloud services and engineers working inside customer operations. That approach follows the buying pressure. A utility utility may care less about winning a general leaderboard than knowing that its model will remain available during a policy dispute. The lab's founder compared model access to electricity. Buyers need diverse supplies, the founder argued, so that nobody can turn you off. There's conviction in that line, and there's also a clear sales pitch from a company advertising European control over European AI. Still, the broader demand shift stands on its own. Export limits designed to preserve American leverage have given overseas customers a strong reason to reduce their dependence on American labs, thus undercutting the profit that those labs might have earned were it not for the ill-conceived export controls in the first place. Open weights makes that possible. Distillation also lets smaller models absorb much of what the larger systems have learned. The performance gap that once justified a closed model premium is therefore narrowing. And China's DeepSeek added even more pressure on Monday with V4-Flash, an open-weight model with stronger agent abilities and token costs cut in half. It trails Moonshot's Kimi K3 on capability, but price and ownership can matter a lot more than that last increment of performance. DeepSeek also paused a pricing system that would have doubled costs during peak demand. Beijing, which invests in DeepSeek, has warned Chinese labs against involution, which is the local term for an exhausting price war that leaves everyone worse off ultimately. Yet state subsidies for energy and compute help sustain that exact competition. That warning protects labs from brutal commercial squeezes. It doesn't erase what the squeeze gives everyone else: cheaper access, more choices, and less dependence on any one provider. The restriction was meant to hold capability in place. Instead, it taught a continent's worth of buyers to build a supply that they could keep for themselves. All right, now we move from who controls a model to who controls the record of where people go. 404 Media obtained a coaching guide from Flock, the company that sells networked license plate cameras to police departments. The guide teaches departments how to win approval before residents can organize against the system. These cameras photograph plates and attach a time and location. But linked together, they create a searchable map of vehicle movements. Flock's guide tells police to script their presentations and privately brief city council members before a vote. Its instruction is blunt: own the narrative before someone else does. Departments are even told to raise the phrase mass surveillance themselves and then redirect that discussion toward the cost of unresolved crime. That is an extraordinary way to treat a public hearing. The answer gets rehearsed with decision makers before the people being watched get to ask the question. Flock's network records everyone who drives past, including people suspected of nothing, and its data has reached ICE. In one documented case, it supported a search across 83,000 cameras tied to an abortion investigation. Earlier reporting also found the network being searched for school residency checks, background checks, and noise complaints. A system purchased for serious crime expanded to whatever an operator decided to ask of it. Richmond and Oakland approved Flock deployments despite public opposition. The leaked guide helps explain how that gap can be produced. A civil liberties researcher quoted by 404 Media said, "This kind of coaching insulates departments from accountability more than it actually improves any public safety." The central problem sits in who gets to see. Police and a private vendor can search the movement of residents. Those residents have no equal way to inspect who ran a search, why they ran it, or where that information even went. Public comment is one of the few moments when the people inside that database can question the people controlling it. The guide tries to narrow that opening before the meeting even begins. Usage logs and audit trails offer a path towards something fairer. A city should be able to inspect every search, and residents should be able to examine how the system is used. Independent auditing keeps getting cheaper, which makes security harder to defend as a practical necessity. The cameras can create shared accountability when the watcher also becomes visible. Flock's playbook preserves the opposite arrangement: observation for the public, preparation and privacy for the institutions doing the observing. And that is the complete reverse of how it should be. All right, our final story returns to the agent breach that helped drive Europe toward self-hosted models. That escape has already produced a new defensive response. 6 days after the report that an OpenAI agent broke out of its sandbox and compromised Hugging Face rattled the AI supply chain, and other breaches were reported in the days that followed, Cogent released VR-1. The company directly cited the breach as a reason for building it. Now, VR-1 is trained to find attack paths. So think of it like an intruder moving through a building where one unlocked window leads to a hallway and then to a stolen key and then to a server room. The model tries to map that whole route before an attacker ever does. According to MarkTech Post's account of Cogent's benchmark results, VR-1 found roughly twice as many of those paths as the general purpose models tested at about 1/4 of the estimated cost. Cogent paired it with Intrusion Bench, a test for this kind of reasoning, and an AI harness that limits what an agent can touch while it works. Now, the early results do need some context. When VR-1 gets no inside knowledge of the target, its success rates remain below 30%. So Cogent calls that preliminary. Comparisons that allow 3 attempts suggest an advantage over strong general models on this very narrow job. So Cogent appears to have built a promising specialist rather than a system that dominates cybersecurity across the board. But then comes the gate. VR-1 has closed weights. Cogent offers it only through a frontier access program for vetted organizations aimed at large enterprises, governments, and defense buyers. The company's safety rationale does deserve a fair hearing. A map that helps defenders close an attack route can help an attacker follow it as well. Broad release, then, can spread both uses. But the current gate that they are doing here sends the strongest new defense first to organizations that already have large security teams. Smaller organizations, which are often easier to breach, still wait outside. Cogent now has to show that vetting follows the danger posed by each user. If access follows purchasing power and institutional status, then the safety program becomes another way to deepen the security gap. The more durable advantage may be the AI harness. It works across different underlying models. That means an organization can place a capable agent inside enforced limits without tying the enclosure to one model vendor. Now, this directly answers the OpenAI Hugging Face failure that Cogent pointed to during the release. OpenAI said that an agent escaped its sandbox during a security test, found a previously unknown software flaw, and used exposed credentials across 4 third-party services before the flaw was finally patched. The model crossed boundaries that the surrounding system failed to enforce. A portable enclosure can spread far beyond one restricted model. Every lab, company, and open model developer can then improve it. That gives the field a common way to turn one costly breach into stronger containment everywhere. All right, closing out for today. Who pays when intelligence moves into the physical world? For years, the easiest answer was everybody else. A new data center could trigger new grid construction and spread the cost across the household bills. A government could restrict access to models and expect foreign customers to keep depending on the same suppliers. A surveillance vendor could collect public movement while keeping its own use of that information really hard to inspect. A security lab could reserve a new defense for organizations already best able to protect themselves. Each arrangement depends on hiding something. A cost, a dependency, a search, or a gate. Those hidden parts are now getting pulled into view. Texas wants the owner, the water demand, the tax break, the cooling system recorded before grid capacity gets assigned. European buyers are choosing models that they can possess and run themselves. Public audit trails can show how surveillance networks are searched. A containment layer that works across models can travel farther than one company's access list. That is where the optimism sits here. Accountability strengthens the build-out by attaching each cost to the actor that creates it. Broad access gives more people the power to improve, to inspect, and to defend what the frontier produces. The infrastructure will be built. The models will spread. The sensors and the agents will grow more capable. So then the open question is, whether a few institutions can keep sending the costs outward while holding the benefits only for themselves. Today's evidence says that arrangement is starting to crack. The bill is finding its way back to the beneficiary. The capability is finding its way out to everyone. See you tomorrow.